the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. Now, this video you're about to see is one of my older videos. The quality is not the same as my new video series. My intent is to make a newer version of this video at some point in the future. However, I want to make sure that students currently using my Mathematics in Review video series have access to as much help as possible when it comes to prerequisite topics. I just ask that you forgive the lower quality of some of these videos. With that being said, let's get started.
The final thing I want to talk about in this lecture, before I stop, is the axioms that build the entire set of mathematics that we use to this day. They're just 10 little axioms that allow us to do everything in mathematics, including almost create calculus. Now, I should note here, an axiom, some people feel as though axioms and theorems are the same thing. Axioms are sort of like theorems, sort of, okay? Sort of like, that's the mathy language right there, roughly equal to a theorem. Except that we don't prove these, these are universally accepted truths. So I'll write that down, universally accepted truths. There are just some things in life that you go, listen, it's true because, well, I don't know, it just is true. Can't you believe me or something like that? I don't know. It's one of those things that that we all just accept as being true. And so there are 10 of these things in mathematics in general. And so we'll go ahead and write them down here. So here goes our generally accepted truths. First of all, we'll just say let A, B, and C all be real numbers. So B in the set of real numbers. Okay, I'm just kind of chicken scratching that out. No offense to any chickens in the audience. So the associative properties of addition and multiplication, those are two properties. Addition, associative property of addition says that if I have two things, well, let's say three things, actually adding A plus B plus C, we will assume that it is true that I could first add A plus B. Remember PEMDAS, you add what's in parentheses first. So we can first add A and B and then add C, or we could have associated it differently and added B and C first. So notice the associations are different. Here I associate A and B, I can add those first, then add C. The axiom, what we accept as universally true, we all just kind of go, duh, it's true because it's true, is that you could have first added B and C and then added A. Multiplication has a similar property. You could multiply A and B first and then multiply that to C, or you can multiply B and C first and multiply that to A. Again, just associating the numbers differently. Commutative properties, well, you commute to work. It's just like moving. Commuting is moving. So these are like the moving properties of addition and multiplication. In other words, if I'm going to add A plus B, I could have added it in the other order, B plus A. We assume that we can do that. Same thing with multiplication. A times B, we assume that's the same thing as B times A. Now, some people say, well, isn't that a lot to assume? Most students would just say, yeah, of course, that's right. I know that's true. 3 plus 4 is the same as 4 plus 3. 3 times 4 is the same as 4 times 3. But the astute student, and I always am a fan of the student who thinks, would ask, well, is this always true? I mean, is it always true that we could do that? Not only is it always true, but does it have to be? What if it wasn't? Turns out there are some systems out there, some number systems that exist where this isn't true. But if it's not true, then math doesn't work very well with them. Okay, there's a special type of This is a very special type of number system that it satisfies all these properties, and if we assume all these properties hold, then everything that we know in the world works out nicely. But if you assume that one of the properties doesn't hold, then things go strange. And it's pretty interesting. You can make some very fun number systems. All right. Additive and multiplicative identities. Well, we have to assume that there's some number in the set of real numbers that we can add to A to get us back to A. And that number we're going to go ahead and call 0. Okay, so that's our additive identity, is that A plus that number 0 will just return A. And along the same lines, we have something that we're going to multiply against A to get back A, and in our number system we will call that the number 1. A times 1 will equal A. And again, that's one of those things that we just go, well, duh, yeah, that's true, right? Additive and multiplicative inverses. Well, if I have A and I want to add it to a number to come out to be, come out to be 0, what number can I add it to? Well, we assume you can add it to the opposite of A. A plus the opposite of A, we are assuming will be 0. Again, one of those situations where most people go, yeah, of course. Same thing, if you want to multiply A by a number to become 1, notice multiplication is all centered around 1, and addition is all centered around 0. What would we multiply A by? Well, it'd be 1 over A. That is the multiplicative inverse. Okay? Multiplicative opposite, you could say. Finally, distributive properties, there's actually 2 of them. A times the quantity B plus C, we will assume that turns into AB plus AC. The other one is quantity A plus B times C will turn into AC plus BC. It's just distributing. You can either distribute to the right or you can distribute to the left. Just to let you know, those are some background theory things in mathematics, but I think it's very important to be able to know that stuff and know that it exists. So from this point forward, when somebody says, hey, yeah, 3 plus 4 is the same as 4 plus 3, you don't have to go, no, it's not. It is. It is, because we assume in our number system it will be. All right, that's enough for this lecture.
Thank you for watching this review video. As I mentioned previously, it's an older video that will eventually be updated. However, it should get the job done for you. As always, this content should be prerequisite to the course in which you're currently enrolled. If you found this material unfamiliar, or if it was confusing to you, then I recommend you review any prerequisite material mentioned in the video. Contrary to my newer videos, these older ones do not have embedded prerequisite links. Sorry about that. If you find you're continually having to research the prereq material here, you might want to consider speaking to your instructor about other course options. On that note, I sincerely hope these videos help you achieve success in your transfer level math and science courses. Cue the music.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.